Welcome. Again, my name is Shane with KETIV. As you can see on the screen here, we're partnering with DLT Solutions and Autodesk for this web portion. And as you can see, we have Justin Ferguson and Blaine from Autodesk. We're thrilled to have them with us. They're going to be doing the bulk of the presentation, showing you essentially some Autodesk tools that help customers solve some complex manufacturing challenges through their additive and subtractive solutions and some advanced CAM solutions. So before I hand the mic over to them, though, I'd like to give a brief intro on KETIV for those that may not know us. As you can see through our slogan there, it's our goal to just help our clients achieve best-class results through successful adoption of proper tools and processes for their business. So Autodesk is a partner with Autodesk, and our focus is purely in the manufacturing space. It's what we enjoy. It's what we do very, very well. And we just want to make our customers better by empowering them with solutions to make their lives easier and their products better. And one of the ways we do this is by freely sharing information with our clients. So with that being said, I'd now like to turn the time over to Justin from Autodesk.
As I mentioned, my name is Justin Ferguson. I'm doing a presentation today, again, we've mentioned, on PowerMill Additive and what the functionality is in PowerMill Additive. I'm going to go over a workflow for a hybrid manufacturing on a 3-axis part, but it'll be on a 5-axis machine. So we can show some of the other functionality that's built into PowerMill that allows the additive to become better than a simple 3-axis tool. So with this, what we'll talk about first is the types of directed energy deposition technology, part classifications, some of the examples that we've worked on, a typical workflow. I'm going to do a demonstration in the software, and then we're going to see a little bit more expansive parts and solutions that are available with what we work on. So the main 4 categories that PowerMill focuses on is inside of directed energy deposition is with an arc and wire, electron beam and wire, laser and powder, or laser and wire. So your arc, your electron beam, and your laser are the ones that are providing the heat source, and your wire or your powder are what are actually providing the material to be able to grow and do the additive manufacturing process. We do have other customers, and we were working with NASA on the Regolith project, and PowerMill is used for deposition of aggregate materials such as a concrete or resin with binders in it. And that is another adaptation that PowerMill can be used, as well as adapting it to be worked on robots so that robots can do additive as well. Today, we're just going to focus on a CNC machine with the hybrid capability. We've taken categories of parts that are commonly done in additive and categorized them into 10 what we'll call part categories. And what you'll normally see in additive manufacturing is what's commonly seen in bucket number 1 or category number 1, which is linear 2.5D extrusions with walls and bricks and things like this. These are parts that you can normally do with a powder bed machine. You can do it with a FFF machine, fusion filament, and you can do it with other types of deposition. Now, when we step up to revolutions, solid buckets, and things like this, this is where you're starting to tip a tool axis so that you don't have only 2.5D anymore. You're starting to go into a 5-axis workflow. Categories 3, 4, and 5 is when you're looking at revolved parts, surface coating, and coaxial features, as well as arbitrary surfaces. The ones on the bottom, categories 6 through 10, are the more advanced technologies and the more advanced application of the additive portion inside of PowerMill and in other ways. The current basic tools that PowerMill has is going to cover this top section, categories 1 through 5, and through a different series of tool paths and different things like that, we can achieve the results that are shown here on the bottom with the coaxial features, the surface coatings, feature constructions that are on an arbitrary surface or on a revolved surface, as well as creation of buckets and 2.5D features. Now, creating a preform is what's really required when you're doing additive manufacturing, because when you take your straight part geometry, and if you were to try to print that, you would have issues where parts may not actually be fully machined when you go to do the machining. So taking your straight part geometry, you need to create a near net shape and then do toolpath planning, post-processing, and then actually go into the manufacturing process. A little example here is a lower aerospace part for the landing gear on an airplane. This is only a quadrant of a quarter of the model. You can see that in the upper middle, this was then done with a wire arc additive process. Then we scanned this information in and then did machining as the last step, lower right. This typical directed energy deposition workflow is to do the modeling for manufacturer, the MFM preform. Then we go into the path planning or the PowerMill additive portion of this, where you then calculate the toolpath, do the toolpath editing, NC ordering, simulation, post-processing, and then you would move on to your subtractive portion of this. So as I mentioned earlier, going from what you call your net shape is the final product into a state that we want to do for printing, we have certain steps that we take. So first we would clean up and remove some features such as holes so that we can then drill and get an exact size of a hole. We want to remove some of the filleting and give a deposition allowance for machining, put in stiffening fillets if we need, and we can then add other steps if we want to have a more realistic shape of what we're printing, and then using that realistic model, then build from that simulation. One thing that we have as well, I'm not going to talk about it very much, I just want to mention it. We do have the ability to simulate this directed energy deposition so that we can do thermal and mechanical simulations of what is being printed. In this case, we'll show the bucket as that heat source and powder or wire gets added to then show how hot this part's going to get. And if we were to do a mechanical simulation, we'll see distortion of the part once we look at that, and we can see if it's actually going to be within tolerance or if it's going to warp too much. So at this point, I'm going to jump into the software, and I'll introduce this as a real basic PowerMill demonstration for subtractive first to show you some of the tools, and then we'll jump into the additive portion and I'll show you how that works. If you've never seen PowerMill before, PowerMill is a computer-aided manufacturing software, or CAM software. It is a process-based manufacturing software, and it uses a very similar interface to a lot of the softwares that we have at Autodesk. We have a ribbon interface at the top, which is what contains all of our tools for programming. On the left side, we have our Explorer tree, and this contains all of the information within the toolpath, within the project. As you can see here where my mouse is, we have our toolpaths. Underneath that, we have tools, and on to see models and stock models, etc., that are associated with this project. We do have our view screen in the center, which allows us to see what's going on and to view simulations of the toolpaths as well. PowerMill has a very linear workflow, so we would start with this home ribbon interface. We would start with toolpath setup, move into creating tools, and then create toolpaths. Once we're done with that, we then do verification if it has not been done already, and then we can run NC programs and then post them and send to our machine. Once a toolpath is then created, we will see the settings form that pops up. And most of the toolpaths that you will see today just one is going to be different. They all contain the same outlook or overview settings look for each toolpath. And it again has a very linear workflow. You work from the top. What is the Z direction that you're moving? What's the work plane that you're using? In this case, we're doing subtractive, so what's our machinable area? The tool that we're using, any limits, and then the actual settings of the toolpath, such as how much material we will leave and the step over of the tool. Now, toolpath creation can be done with a lot of different softwares, and one of the ways that PowerMill sets itself apart is the ability to modify the toolpath after it has been created. So a lot of times you will have segments on a toolpath. For instance, this blue segment here, where the tool will go straight into the part in a plunging move, and some tools are not able to cut on the center of their diameter, and so plunging straight down will actually ruin the tool. Inside of other CAM softwares, you will have to regenerate the toolpath oftentimes to be able to change this. Inside of PowerMill, we can simply choose toolpath connections and change our lead-in move to something more suitable for this cutter. In this case, we can choose a ramp, and we can change our ramp settings to anything that we need. And as soon as we press apply, almost instantaneously, we now have this move that I've highlighted in yellow that will then ramp the tool in, keeping us from damaging that tool. Now, these settings are able to be used, again, in subtractive and additive workflows, so that's one of the reasons why I'm showing this off. Once we have that toolpath, we will see that we have a safety status indicator on the left side, and this indicates to us, without having to run any verification, whether our toolpath is safe to run. So in this case, if I loiter for a moment, you will see the flyout is telling me that the tool is safe, but the holder has not been checked. Now, if I move down to this blue checkbox, you can see that the tool is safe and the holder has been checked as well. And the red exclamation point, I forced it to do a little ouchie or boo-boo or whatever you choose, and it gives you that red exclamation point that tells you, hey, you need to address this and have a look to make sure that you're not going to ruin anything on your machine or tooling. So once you have a little bit of toolpath calculated, you can then simulate toolpath. So right-clicking on a toolpath and pressing simulate will allow us to see then the ramp move that we created and the actual cutting of the material that's going to be done on the CNC machine. I'll speed this up and run it to the end so that we can see what this shape will look like. As we can see, this rough state of the model is, as we would expect, very rough state. As we continue on through programming of rest machining and then finishing, we will get to a point where we want to do some very specific finishing. And when I create a toolpath such as this that's going to finish the walls, one thing that I'll notice again is that red exclamation point. So if I come into my Home tab, we have a button here to view those colliding sections or those exclamation points. And when I click that, PowerMill then highlights the areas of the toolpath that I have issues with my tool. I can then choose to do modifications of the toolpath to then create a safe toolpath. Now, one toolpath that works out really easy to see on is this surface finishing toolpath. And it does show a white checkbox, but if I were to then come into the settings of this toolpath and turn on my verification, you will see that even though I do get that blue checkbox that is showing me that my tool is safe and my holder is safe, I'm not getting all of the toolpath that I wanted. So with this toolpath calculated as such, we know that it's going to have an issue. I can come into my machine tool and turn on dynamic machine control, put my tool on the toolpath, And then I can use the drag handles to tip my machine to a point where it's no longer colliding. In this case, when it was at vertical, we did see that the holder of the tool was shown in red, and we do have this exclamation point here. So we can simply tip it and then drag our tool around on the toolpath to be able to see whether we're colliding or not over the entire area. I can then update the toolpath, and if I were to simulate that toolpath again from the start, we will see that that machine in the 5-axis positioning is able to achieve that as such. Now, this can be done automatically as well. So in the settings of this toolpath, under our tool axis settings, we do have a checkbox to automatically avoid collisions. And so what that does is allows PowerMill to just think of a solution to be able to tip our tool. And as you can see, that tool is tipped a little bit away from the model to be able to avoid that collision. So the reason I said that we went through this subtractive portion again is because all of these toolpaths are then able to be modified both on the subtractive side and the additive side in all of these manners. So if you need to trim toolpaths or you need to modify the way that the tool approaches, it's all customizable within PowerMill, giving you the ultimate control. Now, when we come into the additive toolbar for PowerMill, you can see that we have the creation of toolpaths, we have the editing of toolpaths, and then we can view deposition and then go on from there. Now, as I mentioned earlier, there's only one toolpath that has a different layout. That is our NetFabb toolpath here. And the reason for that is because we have taken some back-end code from the NetFabb program that we have as Autodesk and put it inside of PowerMill. So the settings and the form look differently because it's from a different program. In this case, this is that 2.5D slicing that we saw in the presentation. And you change things such as what's the focal length or the wire length, what is the width of the bead that you're actually depositing, and the step over and the layer thickness, etc., going on from there. Now, more specific options are the surface coating options. Now, this is a PowerMill specific toolpath. This was developed by our PowerMill team, and this allows us to look at that tool axis and actually change our tool axis to be normal to a surface or tilted at all. Feature construction is when you're actually creating things such as the buckets that I showed, as well as the bosses coming off of the coaxial feature. And very simply, you choose what your base surface is and what the feature is that you're constructing, and it'll build your part for you. Of course, knowing what the additive capability of your machine is very important to us. In this case, the part that I'm showing is a mold part. And the story that I'm telling here is that we have maybe used this part quite a bit, and this top section here is no longer producing a part with the tolerances that we need. And so instead of making an entirely new part, we are going to cut away the bad portion, then do additive manufacturing to build this back up and refinish once we're done. If I come back into my simulation and turning this back on, I'm going to then run through my additive prep, which if I unrun it, I can then already have toolpath set up to then cut away this top material that we don't need anymore. At this point, we will then simulate our additive toolpath, and I have a handy button here to be able to view this additive. As we build this part up, we can see the material being added in that we will then come back and machine away. Now the next step is to then do a rest machining of the part. And in this case, having the model shown to us, we don't want to cut air, which is a waste of time. So we have the ability to look at a stock model and add in our additive toolpath. As you can see here, the additive toolpath has been added on this left side. And then calculate a toolpath where in the settings form, we look at the material that we're cutting before, and we have that additive toolpath added here. Simulating this toolpath, we'll see that we will then be able to cut all of the area that we just machined back to the tolerances that we were hoping for. So at this point, we have finished up that manufacturing process of additive and subtractive on the same machine. And so we would be able to go in and then do inspection on this to verify that it is our part that we were trying to get. So what happens when you want to go beyond what I've shown you here inside of PowerMill? Into these bottom categories that we have, 6, 7, 8, 9, 10 for artisanal parts or repair, multi-axis sweeping sections, or blades. In this case, we have other tools that can be utilized. We have Fusion that can be used to help design the parts, PowerShape to help create the preform, and also can be helped to create the setups as well as the design part as well. We can do path planning and path trajectory, and then simulating like I showed you as well. The process to be able to do this, though, sometimes has to go back and forth between PowerShape and PowerMill to do the path planning to get the part that you're trying to get. In this case, we were, as Autodesk, doing a technical demonstration of making a propeller for a boat and then doing additive and subtractive technologies on that. The finished part, again, we finished one blade to prove the technology out, as can be seen in this video here. We also have a little bit of fun with our projects. In this case was a project that we did for IMTS in this most previous year. We worked with the machine builder Takumi to be able to 3D print an octopus and then do it on the same machine, additive and subtractive. Here's a quick video of that process going through. We do have a portion of Autodesk as well that helps with the most advanced portions of that bottom category that we were talking about. In this video, what we have is the adaptive repair process, where we will come in and program the removal of certain areas that we know are actually bad on a turbine blade. Once we've removed those areas, then we have the additive toolpath that comes back to be able to build those areas up, as well as adding extra material so that we can take it back to a finished size. We then bring in the inspection on the machine to be able to inspect the surfaces to make sure that we have actually truly added enough material to come back and finish. We then remachine this area. And finally, we have a polishing tool to be able to polish that edge up to the required surface finish. We'd like to field some questions now for you. If you have any, feel free to type them in the Q&A panel. And if we don't get to your questions today, please feel free to reach out to Shane. His email address and phone number is provided here. I'll actually ask my panelists if we have any questions now.
Yeah, I appreciate that, Justin. Thanks so much. So yes, we do have a few questions that came in. A few that I think might be relevant to the entire group would be, does this require a hybrid machine to be able to do both additive and subtractive, and the stuff that you've shown in general?
It works really well with a hybrid machine, but as we saw in the video with the propeller, we actually had that as an additive process on a robot and then the subtractive process on a CNC. So we have the ability to run both the CNC and the additive as separate machines, but also in the same file so that your data is all in the same place. So the answer there is no. Okay. You do not need a specific hybrid machine.
Okay, and similarly, can you describe how the integration between PowerShape and PowerMill works?
Yeah, so the development teams between PowerShape and PowerMill worked very closely together, and they used the same back-end model. And so what we're able to do is, because they share a lot of the back-end code that's similar, we can copy and paste files from one view to the other view, and even we can do modifications to the toolpath and then copy and paste what we would consider in that case a pattern between the two as well. So if you need to modify the toolpath slightly or create a curve that drives the tool axis, we can go ahead and merge between the two almost seamlessly. Just slightly different tool sets, but definitely very easy to go back and forth between them.
Okay, another one that came in is, will additive replace subtractive?
Well, one thing that's pretty easy to see in that propeller demo is that it's not going to be able to fully replace a subtractive, because in a high rate additive process, you're not going to be able to achieve the surface finishes or the part dimensional tolerances that are called out. And so by doing a process that is very high rate deposition, then you're not going to be able to achieve the tolerances you need, and then you need a secondary process to be able to finish them. Likewise, when you're doing things such as threads or really super precise bores, that's something that additive really can't do very well. So those will need to be done in the standard subtractive method.
Awesome. And if any of you, particularly those answered the question or anybody else on the call, need more particulars or more detail around any of these questions, please just reach out to me directly, and we'll make sure that we just follow up with something one-off to get you get the questions answered to your needs. And a final question that came through is, what kind of training is needed to learn this technology?
Well, it really is advantageous to know both the subtractive and the additive portion of PowerMill. A lot of it is because of the sharing of those toolpath editing topics. So knowing how to edit a toolpath and what it does on the subtractive side definitely helps you understand the concepts of what's available on the additive side. And so learning this is about a 5-day course, but it's all things that we're working together with KETIV and others to be able to provide this material as a week-long course, or depending on how much content is required for this specific software.
Perfect. So that was, that's all the Q&A that I had, unless others come in last second. But please feel free to reach out to me if you have any questions around, particulars around what you saw today, or any other advanced Autodesk solution. So we've shown a couple here today, but some others that are commonly of interest are things like TrueNest for some advanced nesting, or maybe CFD if you're doing any fluid flow analysis or want more information around that, or some of the advanced simulation options available through Autodesk. We want to make sure that we address some of your core challenges, not just with the base Autodesk products, but some other tools that they're pretty deep into as well. If you have a specific rep that you work closely with the KETIV, feel free to reach out to them. Otherwise, you have my info, and reach out to me and I'll get you connected to the right source. With that, any other final thoughts between Justin and Blaine?
I think that's all from me.
I think that's good. Yep. Thanks, Justin.
Right. Well, thank you again. Thanks everybody for your time today, and we look forward to speaking to you guys later.